to remind you of some of the shapes of geometry that I know you're familiar with. We've got your basic square, we've got your rectangle, and we've got all sorts of different shapes. To remind you about a square, the square always has all sides equal. So if one side is equal to 15, then all the sides are going to be equal to 15. If it said that the square is 15 square feet, then you're going to know, okay, well, if it's 15, 15, 15, 15. To find the area, you would just do 15 squared. Same with this. You got 10 here, 5 here, let's say. It's not going to be the same. Each side isn't going to be the same, but you're going to have different sides, and then you're just going to do to get the area, you would just do 10 times 5 is 50. But the one thing that's really neat about, especially, and I won't go into this one, I was just reminding you that there's lots of different shapes, but what's cool about squares and rectangles is you can actually divide them into triangles. And so when you do that, you have these right triangles, and then you can use the Pythagorean theorem, the a squared plus b squared equals c squared. And then as long as you have, let's say you're just told that this square is 15 square feet, then you can actually, if you need to know what this measurement is here, you can find that by using this right here, because this is A, this is B, and this is C. C is always the hypotenuse. A and B are interchangeable. You could use, this could be A and that could be B. So what you would do here is you would just do 15 squared plus 15 squared equals C squared, and then you have to find, if you want to find this length here, if that's part of the problem you're looking at, then you'd want to get C by itself. And what's cool about this is you got 15 squared plus 15 squared. That's the same thing as 2 times 15 squared. Okay, and then that equals C squared. And if you want to get the square, so you want to get C by itself, so you got to get the square root of it, and you want to take the square root of this. This is real easy, because 15 squared, the square root of it is 15, right? And then you still have 2 squared. Actually, you'd want to put a little dot in there, and then that would be equal to C. Another way to write this is just 15. This is a neater way to write it. 15 square root of 2 equals C. So this would be 15 square root of 2. And let's say you need to divide that even further. Let's say you need to find, here's your center point here. You need to just find half of that distance. Well, then you would just divide that by 2. In this case, that would be your, that's half of C. This would be your simplified answer. You could get a calculator out and find the answer as a decimal, or you can keep it in this form, in the fraction form. So that's a couple things to remember. If you end up with something like, let's say you had different numbers here, like 16, and you ended up with 16 the square root of 2 over 2, and you're looking for, let's say in this example, half of this distance here, then you can actually at least do this part, as 16 divided by 2 is 8, so then your answer would be 8 square root of 2. If you're working with a problem where you're being asked to cut up a piece of material, or usually it's like kind of like a cutting problem, you want to be exact in your answer. You don't want to round up, because if you round up and you're trying to figure out some distances to cut, you might end up, your answer might not work, because it won't work in the what you're trying to cut out. It would be, if you rounded up with your answer, then you might not have enough material. So it's better to just be exact with your answers. Another thing you would like to do is just double check your work. So if you get an answer that C equals 15 square root of 2, you just want to put that in your problem here along with your other your other answers, like 15 squared plus 15 squared, and instead of having the c squared later on, you'd want to go ahead and put in 15 square root of 2 squared, and make sure that that is indeed equal to 15 squared plus 15 squared. So this would basically be 15 squared times 2, because you're doing 15 squared and then the square root of 2 squared, which is just 2. And so 15 squared times 2 actually does equal 15 squared plus 15 squared, because that's the same thing as saying 15 squared times 2. So when you're doing a work sample, you just want to think of all the different ways you can double check in your work and different ways that you can solve the problem. Another thing I want to remind you of is, and I'm going to go ahead and erase this, is another shape that's very, that we work with a lot is a circle. And just to remind you, I'm sure you remember this, but a circle has a diameter which goes all the way across from here to here, and then halfway here, it's from here to here is the radius. So the radius is always half of the diameter. So you want to remember that. That's just a pretty basic thing to remember. And so from this, if you were to have the radius of a circle, then you can figure out the circumference, which just means the measurement all the way around the circle. So the circumference is pi 2 pi r, and pi is just simply 3.14. It's always the same number, and then you would just multiply 3.14 times 2 times the radius. And again, because if you're ever doing this by needing to cut out a piece of material, you can also use your calculator for this pi number, because then it's going to be more exact. So those are some hints for working with any kind of geometry problems, real basic problems that you might encounter. And when you're working on your work sample, you just want to make sure that you do several things. What you're going to be graded on is, number one is, they call it making sense of the problem. And you want to get a little bit, you're graded 1 through 6. You want to get a 4 to be able to pass. What you want to do is you want to turn the word problem that you'll get into numbers or symbols, and make sure that the mathematics you use fits the problem that is at hand. The thing you want to do is representing and solving the problem. And by the way, this is just considered like what you need to do, how you're going to do it. So you're gonna use your mathematical problem solving skills and strategy to fit the problem, and you're gonna show all your work, including diagrams, pictures, models, numbers, and or symbols. So do as much as you can with representing, I would suggest. Like if you can represent it as a picture, if you can show exactly what you did. You don't have to use a lot of words on these work samples to explain what you're doing, unless you feel like you need to do it. But if you can show mathematically and it's making sense on how you're doing it, how you're solving it, then that is sufficient. You're going to communicate and reason. And so for that one, that is also considered, it's called the connecting path. Okay, and the path that leads to your complete solution has no gaps for the reader to fill in. If I'm reading this and grading it, I don't have to fill in the gaps and think, oh, well, she or he knew this thing, they just didn't write it down, but they probably knew it. So no, you need to write it down. Every part that took you, now this is all showing your work, you know, what took you from what your setup all the way to the answer. You got to label anything appropriately and accurately. You want to make sure if you have square units, you want to have that instead of just a regular unit. You want to make sure if they're working in meters that you continue to work in meters. If they're working in inches, that you continue to do that. And you want to make sure that you label everything correctly in that regard and use the right units. You also want to make sure your accuracy is, that's another thing you're going to get graded on a 1 through 6. And this is your correctness. So you want to make sure your answer matches what the problem is asking. You want to make sure your answer is complete and justifiable. And you want to make sure you extended your work by asking new questions leading to new problems. That would give you a 6 as opposed to a 4 or a 5. And then you want to reflect and evaluate. And that's your defense. That's very important. This is the one that people kind of leave behind and don't spend a lot of time on. But it's important. You want to state the solution in the context of the problem, of course, using the correct units once again. You want to show that your interpretation of the problem, concepts, strategies, and calculations were reasonable and accurate. And if possible, you can try to work the problem in an entirely second way, a whole new way, just to, that will not only prove your answer is correct, but it also will show that you had another way, there was another way to get about it, and that will show a deeper understanding that you understand the problem and the answer. You always want to check your work too, to show that. You want to show that you're checking your work. And so again, show your answer and all of your work so that everything is clear to the reader. That's what we're looking for. Okay, good luck on that, and we'll see you at the testing.